This glass of water is an example of matter, which is made up of molecules. When we magnify it, we can see its atoms. Within the atoms, we can find its proton, neutron, and electron. If we take this proton and magnify it, we can see even smaller particles called quarks. Conventional idea states that these quarks are the most fundamental particles. Or are they? But before we answer that, let me take you back to 1984 when the world of physics experienced a period of great scientific breakthroughs. As a means of connecting several physical theories, a theory was found to be the most promising. Some even proposed that it is the theory of everything. You see, there's a big problem in physics that scientists have been trying to solve for a long time. In terms of cosmic explanation, general relativity and quantum mechanics are the two best options. General relativity helps us comprehend how massive objects alter the fabric of space-time. Quantum mechanics, on the other hand, seeks to explain the physical aspects on a quantum scale. They do not, however, correlate well together. That's when string theory comes in. Think of the relationship like this.
Stop the wedding!
Without string theory, the relationship will not work out since general relativity deals with massive objects while quantum mechanics works on a quantum scale. In contrast to this, string theory is the thread that connects them both. So, what in the world is string theory? What does the 11 dimensions have to do with it? How does it unify both general relativity and quantum mechanics? String theory states that everything is made up of tiny strings whose vibrations form different particles. According to Greene, deep inside any piece of matter is nothing but a dancing, vibrating cosmic symphony of string. They move and wiggle like little strands of energy. Similar to when I pluck the strings to this guitar, it vibrates and produces various musical notes. The vibration of one string will produce an electron. The vibration of another string will produce a quark. Now, how is the 11 dimensions related to string theory? If we limit string theory to the 3 dimensions we're familiar with, it won't work. Adding 7 extra dimensions and 1 dimension of time is necessary for it to work. But the question remains, however, as to how it unifies general relativity and quantum mechanics. For physicists, the framework of string theory is a way to comprehend how fundamental forces like gravity, which is typically conceived of on a grand scale, may affect subatomic particles. So now we all know that particles are made up of tiny strings that vibrates in 11 different dimensions. But does string theory really answer the theory of everything? Or is it the theory of everything? We don't really know. All we know is that we're headed in the right direction, and you can be the one to discover it.